Well, it is Tuesday here on Trekzone, which of course means it's time to talk science, as we have done every week since the start of April. And to do that with me is astrophysicist and all-round awesome guy, Dr. Brad Tucker in Canberra. Brad, happy Tuesday, dude.
Yeah, how's it going?
Really good. We're in the middle of winter now, but it is warming up here in Brisbane. Go figure.
Well, I was more shocked when someone was like, oh, today's being yesterday, it's 1 July. And I'm like, what? I disagree.
You lie.
Well, it's funny because, we've been talking, since 2019 came around that, the 50th anniversary of the moon landings happening in July. It's months away, blah, 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 and it's in 3 weeks now.
Yes.
Lots to do before then.
It has been absolutely crazy. And one of the things that I've been doing over the weekend is getting together our podcast, our special edition of A Talk in Science, which we recorded with Glenn Nagel a couple of weeks ago. And that's coming out on the 21st of July, which is the week before we head off to the US on our Vegas or Bust tour, which I think is it's just incredible that this has all come around right now.
Yeah, no, and it's nice that it's building up.
Yes.
We chatted with Liz the other day about all the stuff that's happening and all the people coming out. So it should be an exciting time to
be alive.
Yeah, to be involved in space.
Well, before we get started, one thing that I'm trialing now with the podcast, I've been researching how best to do podcasting. One thing that I shouldn't do is shove all of the social media at the end of the show. So if you want to find Brad Tucker, he's Dr. Brad Tucker on Facebook and btucker22 on Twitter as well. He's an all-around awesome dude, and he is posting some pretty cool stuff on his Facebook page, which is really exciting. And of course, if you want to find Trekzone, we are Trekzone.org on Facebook, Instagram, and Twitter. And Trekzone.org AU on YouTube. But Brad, let's get started. Let's get stuck into today's headlines. And something that NASA actually announced on the morning or the day after that we did last week's show, we're off to Saturn.
That's right.
With another mission.
Yeah, to Titan, Saturn's largest moon. And look, Titan's been a source of interest for people for 15 years. Well, longer than that, but definitely 15 years ago when the Huygens probe, which was like attached to Cassini, landed on it, and it discovered this water-rich world. It had rivers, it had lakes. In fact, if you calculate how much water Titan has, it's actually more water. It's about twice the amount of water than Earth has. It's a really water-rich place. And so this gets people excited for looking for life.
Is Kevin Costner there?
Yeah. No, but, just as desolate as the movie. But the interesting thing now is, so NASA in their latest call for missions has announced that it's going to build the Dragonfly mission. So this is going to be an octocopter. So this is an 8-propeller drone that NASA's going to build to fly around the moon of Titan.
And when it gets there, it's going to find a dense atmosphere rich in nitrogen and carbon, just like our own. What are the potential discoveries that we could find here?
So this is why it's really exciting. Like, the environment is fairly Earth-like. In fact, a lot of people quote that it's probably a lot like Earth was 3.5 billion years ago as life was just forming. And this is one of the reasons people want to look for, is not only are the possibilities of life there so strong, and not even just like bacteria or single-cell organisms, like even complex life, but then if we want to see and understand maybe how life arose and evolved on this planet, this is a good snapshot to see what was Earth like, to see what were those ingredients there, and see how life evolved. And now modern technology allows it. So when the rovers land on Mars, they don't go very far. They only go sometimes 20 kilometers over their lifetime. But by being able to build a drone, it should be able to cover an area about the size of California in 2 years. So we're talking about a fairly large chunk of the moon. So, so every Titan day, which is, I think, 17 Earth days, it will land on a place. It will do a bunch of experiments, and then it'll move the next day, and then it'll move the next day, and then it'll move the next day. It's a really cool mission.
Is this the biggest mission that NASA's ever planned, the biggest robotic mission to another planetary body?
At this point, it is, in terms of the robotic nature, right? So this is a completely robotic mission, so it won't be like there's a delay or control. The time delay is hours between Saturn/Titan and Earth, so it's not like you can remote control it. You really, once it lands, that's why you'll give it a full day to do the programming, so it goes to the next place and beams back to data. It's a really ambitious thing, but technologies allowed it. 4 or 5 years ago, drones were not what they were. And now what drone technology is allowing us to do and will in the future means you can build a very flexible, robotic, maneuverable mission that you couldn't do 5 or 10 years ago. So it's really exciting to see and wait and see what it'll take. The one thing we can't change is how dang long it takes to get to Saturn. It'll take 8 years for the mission to get there, which is a bit of a disappointment, but that's the way it goes.
So they're forecasting 2034 for touchdown on Titan, which of course means that it gives them 5 years to design, develop, and get it launched. Is that a realistic sort of time frame?
Yeah, I mean, I think it is. I think they will do it. They have a pretty good mission or a design already. It will take a while. These things are complicated, but technologies allow people to build them pretty quicker and quicker. And I guess unlike, say, Mars, where you have very discrete launch windows, every 27 months or so, there's a launch window to Mars based on its orbit and our orbit. Because Saturn takes a lot longer, there's not as much of that pressure in order to get to that, this very fine window of a couple days. So it should be fine, and it should be able to hit the target. Again, one of the reasons they chose it was because of its doability, essentially.
Well, talking about fast missions to other parts of the solar system, the European Space Agency's come up with some Comet Interceptor missions, and they're calling these fast missions.
Yeah, so these are kind of cool. So what kind of happened was the Europeans are building a new telescope called Ariel, and so this is a new telescope that will measure the atmospheres of other planets around other stars, exoplanets. And then they kind of realized, well, they're going to have about 1,000 kilograms to spare or so in the rocket launch. And so what they said is, who can build a mission that fits, a very discrete parameter? You have to be able to fit this rocket launch, and you have to be able to make the timeline, because they don't want to hold back a whole nother big mission for something like this. So it's kind of an opportunistic thing. Again, it's all about making space accessible. If that rocket's going up, you might as well try and pack as much stuff as you can in there. And so they're going to do this Comet Interceptor mission, which is kind of cool. They'll launch a mission, and then it's going to kind of like hang out around the moon. It's going to like lurk around the moon, kind of creepily. And then when a comet comes nearby, it's going to turn its engines on and jettison towards the comet and attach itself to the comet to take samples and do measurements and measure what it is. So again, it's a really kind of taking advantage of a whole bunch of different scenarios. And again, it's allowing this new technology that we haven't been able to do before, where we can launch a mission and just let it hang out and then be ready to find when a comet comes nearby. When Europe, the Rosetta mission looked at Comet 67P a few years ago, it found 2 of the base nucleides that go into DNA. And so since then, comets have been really interesting. They're not as boring as we thought. We thought there used to be these dirty frozen snowballs, but they're much more than that. So to be able to then now land on a comet and take samples and potentially bring those back to Earth is cool.
So how long is it going to hang around in parking orbit around the moon?
So, and this is the interesting thing, it will wait a couple years until it finds its right target. One of the goals is they want to find a comet that not only is going to come relatively nearby, but also ideally one that is doing its first go into the solar system. So we have periodic comets like Halley's Comet, they go around every so many years. Or there's those comets that kind of have never come in to the solar system before. They do one loop. Sometimes they crash in the sun. Other times they're flung out and then they just keep going away. A famous example of this is Shoemaker-Levy 9, a comet that crashed into Jupiter 25 years ago today, actually.
Hey!
And so, they do these one-time trips. And that means that you kind of have a lot better chance of understanding what the comets are made up of and what's on them, instead of one that's been weathered over the course of centuries.
Well, if you could listen out for these comets, you might also discover something that Australian astronomers have discovered. It's a new fast radio burst, and I have no idea whether that segue actually worked.
Well, fast radio bursts are an interesting thing. So these are these are big bursts of essentially radio light. So imagine like you're in a dark room, and all of a sudden someone turns on a torch and turns it immediately off, and you kind of get this bright flash. Well, this is the same thing that's been happening in the radio sky, looking at radio light. The first one is discovered by Duncan Lorimer in 2007. So they were first discovered by Parkes, the dish, and then other telescopes started to find them. And so trying to figure out exactly what they are has been a big source of research. And so just at the end of last week, Australian astronomers using ASKAP, so this is an array telescope in Western Australia, have been able to pinpoint the exact location of one of these bursts. And so they found it in a pretty far away galaxy. But what they found was it appears to be essentially a neutron star. So when big stars explode, sometimes they form black holes, sometimes they form neutron stars. It's kind of like if you were to pack something the size of our sun into something the size of a city. They're only about 20 or 30 kilometers wide, but they weigh about the mass of a sun. And so they found, and when these neutron stars are formed, they sometimes can spin really fast, kind of like they're giving big bursts of magnetism or big bursts of light. So essentially, they pinpointed the birth of a neutron star.
Wow.
And so, this is neutron stars have been around. They've been a big source of research, and they do a lot of things from being able to use as pulsars for exact timing. Actually, in fact, pulsar timing is used to calibrate GPS clocks. That's how precise these things are.
Oh, wow.
Versus we see neutron stars colliding and producing things like gold. So a very interesting object in space that has been now. It's cool that they've been able to pinpoint the birth of one, essentially.
And that's really cool. And of course, the ASKAP telescope array in WA is the precursor to the Square Kilometer Array, which is it's coming, and it's a worldwide endeavor, isn't it?
That's right. So this is a big, about the size of 1 square kilometer radio telescope. And it's a multinational thing, as we've talked about, that is slowly being built in the Murchison Shire. Part of it will be built in South Africa. And so this is kind of just showing, so this is called like the Pathfinder. It's a 32 array dish, so only 32 telescopes. And they were really testing the new technology and the new way it's going to look at. And it's already doing kind of remarkable discoveries. And that's, I think, the really cool thing, is that they've been able to figure out some of these really cool discoveries that never have been done before using kind of the demonstrator telescope. So you can imagine what happens when the big thing is online.
What I love about this, I was reading the article that you sent me this morning for research. They found this neutron star within 0.12 arc seconds out of the night sky. For someone like me, I don't quite understand what that means, but it sounds impressive.
Yeah, I mean, so you kind of, what we do is if you've put your fist on the sky, that equals about 10 degrees in terms of how big it is. A 1/60th of a degree is an arc minute. So we kind of divide it in 24 hours and we divide it by a circle. So we get, and then 1/60th of a minute is an arc second. So it's 1/60th of 1/60th of 1, which happens to be 1/10 the size of your fist held at an arm's length to the horizon. So, I mean, we're talking about a pretty fine, minuscule pointing accuracy.
I think someone went a bit crazy with their mathematics skills.
Yeah.
They came up with that system. Hey, what I love, and the other thing that we have to talk about too, is the naming conventions that astronomers come up with. FRB 180924 is what you guys have designated the signal as. How do they come up with this sort of stuff, Brad?
Well, so it's interesting, and everything has a naming scheme. So the FRB means fast radio burst,
okay,
and so that's the date it was discovered.
Okay,
right.
All
right. So 18 would be 2018, and then month, and then day.
Okay.
Now, if you happen to find 2 on the same day, you call one A and one B. Then second one B. So this kind of started with gamma ray bursts. We started to call them GRB and then the date, and then we'd add A or B. So then fast radio bursts followed a very similar thing, and so do gravitational wave events. We call them by the date. Now, the reason we do this is one of the reasons why is if we were to say, call it, some like stars have these really long telephone number names, and that's their actual position in space. But a galaxy could actually host 2 different types of explosions. And because it's so far away, that position is going to be the same. So that could actually be a bit confusing. So that's why we just call it based on the day, because it's also not debatable. If this is the first time that we saw something, that's just the beginning of that event that we know of.
All right, so there is method to the madness.
There is method to the madness. It's not a great method, and it is madness, but there is method to the madness.
Fantastic, Brad. Well, as always, thanks for talking science, and we'll see you next week.
Definitely.
Get exclusive access to podcasts, behind-the-scenes info, and uncut editions of the show by becoming a member on Patreon today. Support Australia's unofficial home of Star Trek. Get even better with membership starting at just $1 a month. Jump over to patreon.com/Trekzone.org.au. You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Get the wrap-up on our Facebook page. Keep in the loop on Twitter and relive Trek episodes on Instagram. Plus, you can catch the latest podcasts on your favourite podcasting app. New content is being added all the time to Trekzone's YouTube channel, Talking Science with Dr. Brad Tucker, as we've done today on Tuesdays. Trekzone Live on Thursdays following Vegas or Bust, and a Trekzone Conversation now on Saturdays. Don't miss a moment. Subscribe and ring the bell to be the first to know about new eps. As always, a huge thanks to Brad for co-hosting with me and bringing us all the science and space news every Tuesday. You can find him on social media, Dr. Brad Tucker on Facebook, btucker22 on Twitter, or indeed right here next week on a Trekzone Conversation.